This is on page 688. And when it's written in words, it's a little bit confusing. If there are n1 different objects in one set and n2 different objects in a second set, then the number of ways of choosing one from each set is n1 times n2. What they're trying to do here is saying, if you had two decisions, make a space for each of those decisions, and then you put your number of choices for decision 1 and number of choices for decision 2 and multiply them together, you will get the total. If there are more decisions, you have more spaces. So whenever there is, they say one set, that's like your first decision. And then how many choices are in that set, how many different objects, is how many choices you have. So now we can use this to solve all sorts of questions. This is no longer true. The minimum security standards that they would say, you're going to have a password that's 2 letters followed by 5 digits. Hackers are going to love this. Because that's actually not too bad to hack. What are passwords now? It's like, you have to they're getting terrible. It's like you have to have at least 10 letters, has to have at least a capital, at least a number. Like those special characters, don't they drive you crazy? So it's like, oh.
I had to make up the password on the spot for work the other day. 15 with a capital and a lowercase, number, special character,
and sometimes it's like, some of the passwords that are like, you need all of these things for security. And it's like, it's my library card. No one's going to go and want to sign out a library book under my, like, this probably doesn't need high security. I can understand banking, but other things, it's sort of like, okay, we're getting a little bit crazy with security. Anyways, but 2 letters followed by 5 digits, how many passwords could be made? Well, this would have 7 decisions. So what we're going to do with our decisions is not only are we going to draw the spaces, but underneath, we're going to have just a simple explanation, and it can be as simple as this. I'm going to use L for letter and D for digit. All letters and digits can be used more than once. How many passwords are possible? So how many letters are there? Oh, we have to know our alphabet. 26. English alphabet has 26. Other alphabets have less. So what's the Hawaiian alphabet? Only 12 letters? The original Hawaiian alphabet? Something like that? Now we'll have to look it up. 26, and we could argue here, some people might say that we should write 52 because it could be lowercase or uppercase, but we'll just go with 26. Then you would still have 26 choices here. How many digits are there? 10, because you include 0, right? So 10, 10, 10, 10, 10. And you get 26 times 26 is 676 and 5 zeros. Wow! Even though that's a bad password, there are 67 million possibilities. Still pretty good. Your chances of guessing it right would not be very good unless I was guessing one of your passwords and you'd be like, oh, my password is CD12345. Well, sometimes we choose bad passwords because we want to pick something we can remember. They're like, oh, I'll just use my initials and then 12345. And then the password hacker gets in right away because they can predict things. So lots of passwords. Once you get into those special characters and capital letters and numbers, okay? You know what they make for my, I shouldn't give it away. Pause the video. My password to get into the school, they give us 4 random words in a row. And then a number, and then a special symbol.
That's pretty sick.
That's a lot of, it's pretty hard to break in 4 random words in a row. I wanted to hack into it and pretend that someone's new password, and then just have a bunch of, like, what do you think of when you think of 4-letter words? Swears? Most of swears are 4-letter words. I was gonna give a teacher a new password and it was all swears. Okay. So questions for practice on this one are, oh, there's one. 5, 7, 8, 9, 10, and 16. And I put a star by 16, which means maybe it's hard. Hey, just for fun, let's do license plates in Manitoba. Does anyone know how license plates in Manitoba work? There's 6 things, so there'd be 6 decisions. Anybody know what they look like? You ever paid attention to a license plate? 3 letters, then 3 digits. And so you have 26, 26, 26, 10, 10, 10, which is a big number. Seven, 5, 7, 6, 0, 0, 0. 17 million. Have you ever seen a car from Ontario? Have you looked at their license plate? They have 4 letters now. Because they ran out of license plates.
If you did the whole 10 meters,
That's a lot of cars,
you'll mark down.
right? So we need to be able to put these things in to be able to count to find out, okay, when are we going to run out? How many different possibilities are there? And with passwords and the internet, there is computers. It would not take them long to check all 676,000 of them. Right? So have you ever been on a password where after your 5th attempt, they say you're now locked out? Which is kind of good, because if they didn't lock you out, there would be bots out there that would just keep trying passwords until they got one that worked. It wouldn't take them that long. But those lockout things, it's like, you get on the 4th one and they're like, you have one more try. And you're like, do I do it? Do I try this one more time? My personal pet peeve is Ticketmaster. Ticketmaster gets me every single time. I'm like, try a password. No. Try another password. No. I'm like, you have one more attempt. I'm like, oh, okay. Because I know if you're locked out, then you have to phone in. So it's like, so you click that, I'll reset my password. So I go to reset my password. Comes the thing, and you go to reset it, and it says, sorry, you're not allowed to use that one. You used that in the past. Well, yeah, I want to use that one so I remember. They make you pick one that you're not going to remember, and then every time you get to Ticketmaster, you can't log in because you just picked a new random password that you're not going to remember. So I don't go to concerts. Just easier to avoid altogether. Oh yeah, that's 8.1. Here we go. Little mental math to start. Without a calculator, figure out the following. And then once you you've done the mental math, I want you to try the question at the bottom. See if you can figure out how many decisions need to be made and how many choices you have. Okay. Curiosity for the first one. How many people did this in their mental math for the head? They did 4 times 3 times 2 times 1, got 24. 3 times 2 times 1 is 6. 24 divided by 6 is 4. Okay, how many people did that? Okay. How many people for mental math on this first one went 4? Okay. That sounds like a little bit weird, but how many people in mental math on this one just went 30? Okay. So that seems like, how did you do that? Because, right, 6 times 5 times 4 times 3 times 2 times 1, how many people know that that's 720? Uh-oh. 720 divided by 24 is 30. But isn't it easier if you just simplify, right? Get 30. This one, still a little bit harder. 8 times 7 times 6. What might you do? You might do 2 of those first and get 56. 56 times 6, and 50 times 6 is 300. 6 times 6 is 36. To get 336. Okay, try the question at the bottom. Sometimes decision questions are, like counting questions are a little bit disguised. Right now they're not disguised because we've learned one strategy. When we get to the point where you have 10 different strategies and you have to know which strategy to use, this unit gets hard. When you have one strategy and you're like, which strategy should I use? The unit is easy. So we have one strategy. That's our spaces for decisions and choices in those spaces. Can you figure out how to do that with this question? How many decisions do you need to make? Can you label your decisions underneath? And how many choices do you have for each one? I don't know if you've noticed, but this unit is different than any other unit we've done so far. You don't need to know trigonometry or logarithms to count. Did you see that you need to make 2 decisions? You have to go from, I guess you could label this decision as going from Vancouver to Vancouver Island, and this decision is Vancouver Island back to Vancouver. How many choices do you have for your first decision? 4, right? Because there's 4 ferries, you can get on any one of them. But then on the way back, you have to choose a different route, so now how many choices do you have? 3. Then it would be 4 times 3, you would get 12 in total. If they added a new one, do you see it'd be 5 times 4 and get 20. If they added another new one, it'd be 6 times 5, and then you would get 30. Now, this idea where something gets used up and you can't use it again is something called a permutation. So we can start our video here. Oh, we didn't stop the lecture. We've been recording for a long time because I used the 10.